Hi, this is Hema Kadia from TeckNexus. Welcome to our 5G Fireside chat series. Today's topic is network slicing and splicing, specifically in Industry 4.0 use cases. For today's session, we have invited Vas, CEO of Zeetta Networks, and we are going to speak about network and splicing and how exactly Zeetta Networks is helping industry implementation of the 5G use cases. Welcome, Vas. Appreciate if you can introduce us to Zeetta Networks.
Hi, nice meeting you. Hema, thank you for inviting us and presenting the use cases for the Industry 4.0 and obviously what we are doing in the UK and especially in this particular deployment for 5G in industrial context. I would like to take a few minutes to introduce myself and the company. Obviously, my name is Vassilis Seferidis. I'm the CEO and co-founder of Zeetta Networks. Zeetta Networks is a spin-out from the University of Bristol. We have been operating for the last 5 years, and the focus is very much about network automation, especially applied in enterprise networks and increasingly in private 5G networks. The company develops software tools that simplify the network operations and make it as easy to deploy private 5G networks as it is to deploy a Wi-Fi network.
Thank you, Vas, for that introduction. Let's start with the setting the expectations, what we plan to discuss in this meeting. First of all, we would like to go over what exactly is network slicing and splicing, and then we'll go over some of the use cases that you have implementing with various projects. So let's start with what exactly is network slicing, and specifically what exactly is network splicing, the term which has been coined by Zeetta Networks.
Yeah, sure. I mean, network slicing must be quite familiar to a lot of your audience. It is basically the definition of an overlay network, a virtual network, basically a logical network that can be isolated and provides basically the isolation of a use case, a user group, or a devices that you want to isolate and deliver a special service to them. The typical example in the 5G environment is when you want to isolate the low latency applications, for example, from all the other applications. And then you isolate these low latency applications in a special a construction logical network, which we call network slice. The importance of that is that obviously make the whole utilization of the network more efficient because you use the common physical infrastructure. Those are logical networks that run on top of the common infrastructure, which makes the use of the network even more efficiently.
Absolutely, absolutely. So, Vas, you mentioned that you've been working on the 5G encode project, which has multiple Industry 4.0 use cases. Can you elaborate exactly what is 5G encode project and what are the typical use cases where you're leveraging network slicing?
Yeah, if we go to the previous slide, because it is important actually for people to understand what is the network splicing as well.
Yeah, absolutely, absolutely.
Which is a very important use case for the 5G encode. Network splicing is all about combining, if you like, or joining network slices that you have created in the previous in a physical infrastructure in order to actually provide end-to-end services across different domains. And what we do basically here is that we combine, if you like, the pipes of connectivity that we create with the network slices, and we can combine them to actually provide a more consistent service across end to end.
Got it. Got it. Thank you, Vas, for that clarification. So you're moving on for the 5G encode project that you mentioned. You mentioned that there are a number of 5G use cases that you're working and you're leveraging both network slicing as well as network splicing for supporting these use cases. So let's go over briefly what are the use cases.
Sure. I think the application that actually makes and brings the network splicing and slicing in prominence, I guess, is the one on the left side, which is all about the in-factory and in-transit of asset tracking.
Okay.
Obviously, I guess most people understand the in-factory asset tracking. Here is the potential basically to track different assets within the factory as they move around the factory, the factory floor.
Yes.
And you want to actually locate them wherever they are. In this particular case, in the deployment we have in the 5G encode project, the deployment is in the National Composite Center, where the assets are basically chemicals that they have very limited life cycle. So they have to be used within an hour or a few hours, which means that you have to track them to know where exactly they are as they move around the factory floor, so they can be used within the time limits that we have. And they have to be monitored continuously throughout this sort of journey from the creation or the moment they arrive from to your factory door until they are used by the machines within the NCC. Now, this is obviously to improve the productivity, because you know, and you don't waste time to actually finding the resources.
Yes.
But also obviously to know where exactly things are, right? Like a better maintenance of and reduce costs. The more important thing, and where the network slice and splice comes into play, is that we can allocate, of course, a dedicated network to actually track the assets as they move around the factory. That's within the factory.
Okay. Okay.
The network splicing comes to play when you want to combine and you want to track the assets as they move to the factory and they go to another factory across the city. Then they have to actually start the journey from one private network, which we deploy in one location, to the public network from an operator like Telefonica in this case, and to another private network to the other factory. What we have then is you want to actually create slices in the factory, the originator factory. You want to create a slice within the public network, Telefónica's in this case, and you want to create a slice in the destination factory, and you want to have a join all these slices, the independent slices, so you can have a seamless transition of your service from one private to public and then to private network.
Absolutely.
So that's the use case of the in-transit asset tracking that is very important for this particular network and the implementation we have in this project, but very important for logistics applications as well.
Got it. Got it. And also you mentioned about this closed loop manufacturing. Can you also elaborate a little bit on that use case as well?
Sure. So this is a very much a ultra low latency sort of application. I'll explain a little bit what we're actually doing here. There is this machine in the factory floor, which is called liquid resin infusion. This is all about stuff applying resins, which is basically chemicals, something like a glue, I guess, to structures that have been like skeletons, which are basically things like sort of plane wings and chassis for cars and things like that. So quite big sort of constructions.
Yes.
So the manufacturer will be preparing that, and they will apply resin in such a way that actually sort of pumps the resin from one point and then sucks it from the other with a vacuum sort of machinery.
Got it.
The process is very time consuming, so it takes some time to actually complete, but it's also very, very delicate in the sense that you have to monitor the process, because there can be like sort of errors all around the place. It requires a lot of expertise. And human expertise. Just because of that, they want to automate this process. If you, just to give you an example, if you just make a mistake, that can translate to maybe 50,000 sort of pounds of cost, right? Because you just have to throw away the whole plane wing, because that's the prototype you are building there, right?
Got it.
In that case, you want to monitor the process as it happens in real time, ideally. What they have today is they have about 10 sensors monitoring the process, which takes usually a couple of hours, and they adjust basically the application of the resin as it goes. The problem they have is that in order to make this process more precise and more, error-free, if you like, so they can do it, correct, they have the perfect sort of prototype the first time round. They're going to introduce more sensors. They're going to go to 100 or 200 sensors. Now, the existing sensors are connected with, the data collection machine to the server through this kind of cables, Ethernet cables, basically. And of course, moving to 100 or 200 of units introduces the element of scalability. They don't have enough sort of cables to actually manage there, right? They don't have enough space to actually sort of manage this complexity. Absolutely. And that's why they will start thinking about the wireless. They can still use some, the wireless technologies existing in the moment, the Wi-Fi, for example, but that doesn't allow you to Wi-Fi doesn't allow you to actually control the network to the level that you want with a very low latency. Just to give you an example, they're going to collect all this data, process them, and of course, develop the feedback loop sort of applications within 5 milliseconds. So in order to do that, they need, obviously, the wired solution is the best in terms of actual latency.
Yeah.
But the Wi-Fi solution has to provide similar type of, speed, right?
Yes.
And that's where they came to a mobile sort of environment, a private mobile sort of a deployment, where they can control these parameters in a more sort of detailed environment, right? And more, precisely.
Understood.
And that's what we're doing for them. Now, as I mentioned, just by doing this process in, improving the productivity of that and reducing the yield,
Yes.
that can actually save, hundreds of thousands of dollars in the factory.
Yes. So as you mentioned about these 3 use cases, and you also mentioned that you are doing the network slices across 3 networks. One is the fiber network, one is the mmWave network, and the third one being Telefónica's 5G network, public network. And so the question is, how exactly you're doing the network slicing across all these 3 networks, across the 3 locations, and supporting the use cases that you just highlighted?
Yeah, I mean, we have a slide here and a small animation that actually provides some bit more detail of what we're doing here. So we have 3 locations. The NCC is the National Composite Center headquarters. The NCC Filton is another location of the same company, which is in maybe about 6 miles away. And then you have, of course, the Millennium Square, which is another sort of deployment of the university's, the University of Bristol's deployment of a private network, which is again in the center of the city. Now, these 3 locations have each one of those their own private network. So you have like obviously the RAN, the 5G core, and the MEC all in one location, right? So it's like a self-contained environment.
Yes.
The black box you can see there is basically Zetta's technology, what we call Netos Rapid, which allows us to actually do the slicing of this access network of the independence of private networks. So we are able within this each one of these environments to define pipes of connectivity from an access point, like in this case a small cell, from the RAN,
yes,
to the MEC and to the core, through the core to an access point, right?
Got it. Got it.
And we do that in each one of those locations. Now, these locations are connected with each other with 3 different types of networks. Obviously, you have the public 5G network from Telefonica connecting, the whole city, and of course, the 2 locations of NCC headquarters and Millennium Square. We have a millimeter wave network, which is basically connecting 60 gigahertz network, connecting the NCC headquarters with the other location of NCC Filton. And you have the fiber network connecting the NCC Filton with the Millennium Square. Each one of those transport networks is sliceable as well. Or obviously the Telefonica network is sliceable by Telefonica's own slicing technology and slicing the core. The millimeter wave is obviously controlled by NCC, so it's sliceable and we have access to that and you can slice it. And the optical network is the same thing. It belongs to the university. And it is also a sliceable network in the optical layer. So our multi-domain orchestrator, what you see that as a blue software layer, allow us to create slices in each one of these individual locations, but also create slices on the transport networks as well. And more importantly, once you have created these slices, obviously, you can actually join these slices with the process that we call network splicing. So you're just joining the different slices. If you press, probably the guys can actually see those are the slices that you can create in the transport network, and then the yellow circles represent the splicing of that, where you can actually combine now the slices of the different transport networks with the local area networks to have the end-to-end delivery of service. And all these slices, of course, are depending on the use cases that you want to support. If there's a low latency application, you can create a slice in the local in the private network, which is a low latency, 3-5 milliseconds. you request a similar slice from the Telefonica network,
Mm-hmm.
which is obviously, delivered in a way of APIs and hooks there, and provided to there.
Mm-hmm.
And then you have another sort of slice from the other private network in the Millennium Square, so to complete the end-to-end sort of slice with these special KPIs.
Got it. And Vasi also mentioned that your orchestrator out here, it may have to interface with the, whether it is Telefonica's orchestrator or SDN controller or the independent way they are managing the slicing and so on. And it could be different for different enterprises and different operators. So there is a complexity from that perspective as well, beyond the network slicing in the overall orchestration. Can you also elaborate like what were the key
Sure,
things
sure.
you have to take
So
care
our technology is very much sort of software-defined networking technology, so that is vendor agnostic and technology agnostic. That means that we can actually slice any type of network, from the transport network, the fiber network we discussed earlier, and millimeter wave, to LAN and any type of network, and obviously sort of interface with any of the vendors. So it's basically a software-defined network technology, which should be supporting disaggregate solutions and able to support different services.
Absolutely. So, was the following question would be that this is the architecture that is allowing you to really do the network slicing and splicing and support the use cases. What are the key technologies and the products that you're leveraging, both Zetta's network as well as there are some partners that you've involved in this 5G Encode project. So, can you elaborate onto what are those key products and technologies both from Zetta and the wider industry?
Yes, I mean, I mentioned earlier the network's rapid box that we represent in each one of those sort of locations with a black sort of square.
Mm-hmm.
This is basically a deployable version of our NetOS SDN controller.
Mm-hmm.
Our SDN controller is basically an Open Daylight deployment, a special sort of version of the Open Daylight controller, SDN controller, which is has been augmented with a lot of orchestrations of tools and extensions which support different types of devices.
Okay.
That allows us to actually, as I mentioned earlier, to slice the network, the private network, in one location, in one domain, and allow you to actually define pipes of connectivity, VLANs, the level of slices that you want to create in a single domain sort of environment. The NetOS Rapid is the deployable version of that. It's basically a box that will actually bring it to a factory and provides you with this capability. It's a pop-up network, if you like, that actually provides you this kind of control and sliceable stuff capability.
Understood.
Our network splicer or net splicer is all about splicing the different domains. So you create basically the individual network slices in each individual domain, and the network splicer is actually combining, or you can call it basically sort of multi-domain orchestrator, for a better word,
Mm-hmm.
which basically combines the slices and makes the control and orchestration of your network end to end. For us, orchestration of the network is all about managing slices. So everything in the network is a slice, and the service you provide is a slice, and you're just managing different slices with the orchestrator, either in the single domain with the NetOS or with the net splicer, which is like in a multi-domain orchestrator.
Got it. Got it. So, the following question would be beyond the 5G Encode project and the Industry 4.0 use cases, what are the other use cases where you're planning to leverage the network slicing and splicing concept? If you can give us some preview on that.
Sure. I mean, we have been involved with some other interesting projects, applying the same basically technology in areas like logistics, for example,
Mm-hmm.
entertainment. Logistics is very much similar to what I was describing earlier about asset tracking. You have the asset and you want to track it across the different private and public networks. This is a typical sort of use case for logistics sort of environment. And you have, of course, the other very interesting sort of deployment for us is the smart venues, places that you want to actually automate a lot of functions. You want to specify new services and deploy different services, but also have the network automation to simplify this kind of deployment. And what we call mode management, moving from one configuration of the network in your venue to another one with the press of a button. Is very useful for venues, for example, that they have a multi-purpose. For example, I'll give you an example that we have implemented in a stadium. The stadium can be used as obviously a sports sort of venue, but increasingly so it used as a hospitality, for wedding receptions and hospital concerts, conferences, sort of industry events and the likes. So moving from one style of configuration, one mode of configuration to another with the press of a button, reconfiguring the whole network in one go is what we can offer with that, right? And delivering all that through network slicing and splicing in an enterprise environment.
Got
So
it.
that we see as another application for the 5G as we move to the 5G and we move away to apply the same technology in kind of sort of hospitality, if you like, or multi-venue, smart buildings, smart cities of environments.
Thank you, Vas. Thank you, Vas, very much for this very informative session. We appreciate your time and we look forward to speaking to you in future sessions. Thank you again.
Thank you. Thank you for having us.